All right, let's check those answers. Give yourself a completion score out of 10, 4.2, page 228. If you need more time, you can go ahead and pause. Here's the second part. One thing I want to say about 19 and 20, I knew that you would struggle a little bit, but what I want you to check is to see, did you get these equations set up? Did you know that this 12x plus 4y would have to equal 40? And did you figure out that this little guy is 50? And so then 17x minus y equals 50. That's what I'm looking for mostly, to make sure that you have the geometry part set up right. Now after that, you would have had to remember some Algebra 1 solving systems of equations. In this case, they took the second equation, multiplied everything by 4, and then what they did was use the elimination method to add those together. You'll notice that the 4y and the negative 4y eliminate. And so then you're able to find x. I think it's worth doing that problem because in Algebra 2 you'll be expected to know how to do that, but when I quiz and when I test you, I'm not going to ask you to do a system of equations problem. Pause me again if you need more time. And today's lesson is a shortcut for what we did yesterday. Today we are doing the side-side-side congruence postulate. So you can go ahead and write this on your note sheet. If 3 sides of one triangle are congruent to 3 sides of a second triangle, then the 2 triangles are congruent. And we sometimes call that the SSS Congruence Postulate. It's just standing for the fact that we have a side congruent to a side. Would you like to draw one of these little diagrams? You certainly could. So what we're checking is to make sure that all 3 sets of sides are congruent. Now can I show you, remember the proof that we did yesterday? Remember I told you that it was going to have at least 7 steps because we had to get all 3 sets of sides congruent. Well, what the side-side-side congruence postulate does for us is it makes it so that we don't have to mention all of those angles. Because once we show the side, the side, and the side, the angles are guaranteed, so we don't even have to list them anymore. So it'll be sort of like a shortcut for us. Instead of listing all 6, we're down to 3. An application of the side-side-side congruence postulate is that these triangles are stable. We can only make one triangle. We can only have one possibility for those 3 angles, as long as those sides are fixed. And so when you think about it, if you have, let's say in this barn, these doors are reinforced with triangles because that means that those angles aren't able to move anymore. Where if you think of the same thing with, let's say, 4 sides, on this one I've got side, 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 side. But those are not congruent figures because the angles aren't automatic. It can sort of collapse. Even though the sides are all the same length, it can sort of collapse. So let's say a shape like this, would that be very stable? Can you picture it kind of slanting over and making a rhombus? So not stable. How about this one? Can you see any ways for that to sort of collapse? Since it's made out of triangles, those angles are fixed. We can't collapse that figure. And this one, this top triangle is fixed, but this bottom one, can you sort of picture the bottom part wiggling back and forth? So anytime you have anything more than 3 sides, you have a chance that those angles might change. This is the chapter where some students think proofs start to get fun. For real though, because they're just not as complicated anymore. You sort of find the pattern and you get your flow. So let's start this one. We are given one set of congruent sides. That's nice, because we know we need 3 sets before we can say that the triangles are congruent to one another. So those triangles look congruent to each other, and I already have 1 set of sides that is ticked. Our goal is to tick 2 more sets of sides. We also have the sweet given G is the midpoint. Go ahead and write that down. Of side FH. Now, I'm going to skip ahead, you guys. As soon as I see the word midpoint, I'm expecting the definition of midpoint to come up in my proof. Can we look at what that means? So looking at the picture, if I told you that G was the midpoint of segment FH, does that allow me to tick some things? And the answer is yes. The definition of a midpoint says that that's right in the middle. So I could write that side FG is congruent to side GH. And then I've got another set of sides that are marked. Now let's think, which set of sides don't we have marked? And it's like the JG side. You know what I mean? Like they're both sharing that same side. So obviously the JG on triangle number 1 and the JG on triangle number 2, they match up perfectly. So I can confidently put a triple tick there. Do you see why that might be called the reflexive property? I'm going to say that side JG from the first triangle is congruent to side JG from the second triangle. And that's the reflexive property. Of course, JG equals JG. So there's our third set of sides. That's why I like to put these S's here, because as soon as you see 3 of them, you're ready for the punchline. And the punchline is that triangle FGJ is congruent to triangle HGJ. And you'll see right here our new reason, the side-side-side congruence postulate. All right, here's our last example. I actually want you to pause for a minute and see how far you can get on this proof without me. And I'm thinking most of you are able to put in the givens, yes? Did you put any S's next to any of those givens? And the answer is you should have put an S right here, because anytime something allows you to give yourself a tick, hopefully you did that on the diagram too. Anytime you put down a tick on the diagram, you can put an S in your proof. All right, so we have 1 set of sides. Did you see the word bisect? Whenever you have a given with a vocab word, you're going to wind up using the definition of that bisector. It looks like it's a segment bisector, right? Okay, and they bisect each other. So we actually sort of have 2 bisectors, which we'll be able to use. Let's look at each one. GT is bisected, which means I can tick GO and OT. GO and OT are congruent. It's another set of sides that are ticked. And where's my other one? ME is bisected. So I can tick those 2 sides. Mo congruent to EO, whatever you want to name them. So the order of the letters doesn't matter to me. You could call that EO or OE. And that's our third set of sides that is marked. Now the punchline, triangle GO is congruent to triangle TMO. And our reason, we've been keeping track. It's the side-side-side congruence postulate. Pretty sweet, right?